Back to fractions. When you're multiplying and dividing fractions, do you have to have the same denominator? No. Any fraction can be multiplied by any fraction. They don't have to be the same. Well, guess what? Any variable can be multiplied by any variable. Same rules. Adding and subtracting, they have to be the same, but multiplying and dividing, anything goes. Okay? So what do we do when we actually multiply variables together? We add the exponents. Because x squared times x to the fifth actually means that we have 2x's times 5x's for a total of 7x's being multiplied. So the rule for multiplying monomials, add the exponents. We're going to combine the letters that are the same by adding the exponents together. This should all be reviewed right now. And the only reason I'm moving slow is so you can get these notes down. Alright, so if I asked you to multiply these two expressions together, x squared times y cubed multiplied by x cubed times y to the fourth. We can actually combine the x's and the y's, right? And the way we do that is by adding their exponents. I have 2 plus 3x's. I have 3 plus 4 more y's. So my final answer is x to the fifth times y to the seventh. Now, do you have to show this step right here? No. You don't have to show that step when you're solving your stuff. I'm showing it so that everyone can see exactly what we've done. Okay? Suppose I add a coefficient in front. Okay? Multiply the coefficients together just like you normally multiply numbers together. 3 and negative 4 multiply to give me negative 12. X to the fourth times x to the first. 4 plus 1 is 5. Y to the sixth times y to the first. 6 times 1 is 7. Or 6 plus 1, excuse me, is 7. So your final answer here would be negative 12, x to the fifth, y to the seventh. Dividing monomials. When we multiplied, we added the exponents. When we divide, we're going to subtract the exponents. Because what we're dealing with here is that you have 3 x's in the numerator being multiplied and 1 in the denominator. Well, 3 minus 1 leaves me with 2, correct? All right. Now I'm going to show you a process to go through to make sure that you get your letters in the right place. We know that we subtract exponents. But what if when I subtract I get a negative exponent? And then I've got to invert. And there's all these rules I have to follow. It's very simple. When you see an expression, start by identifying where do I have the most x's? In the numerator or the denominator? So you know that your x's are going to be in the numerator because you have more. Then simply subtract the two variable exponents and put it there. Don't worry about it being negative or positive. Just put the answer. 4 minus 2, 2. Where do you have more y's? In the numerator. So put a y in the numerator. Now subtract 3 and 1. What do you get? 2. It's y squared. Where do you have more z's? So put z in the denominator. Now subtract. 5 minus 1 is 4. Okay? It's that simple. Identify where there are more, and then show what you have left. And what happens when this takes place? You got negative exponents, you got positive exponents, we got to subtract, we got whatever, okay? Too much to handle all at once. So my suggestion to you is, before you start working with this problem, fix all of your negative exponents. Identify all of the variables that are following the instructions, take the inverse, and do that. Which means that in this particular fraction, x squared needs to do what? Come down. Z to the negative fifth needs to come down. And all of these need to come up. So I'm going to rewrite my expression. Hold on, I added this later. I'm going to rewrite my expression with only positive exponents.
Can you do it whenever it's not?
Can you do it straight from here? Yes, but you may get a little confused. Okay? I'm just saying, yeah, you can do it. It's just a lot more room for error. But yeah, if you can do it straight from here, then do it. Follow the rules. But your answer, now I look and I say, okay, where do I have more x's? In the numerator. So I know that in my answer, I will have an x in the numerator. How many? 3 minus 2 is 1. I have 1 x left.
I don't get it.
No, say it.
Well, we're not there yet. I don't get why z is in the
Because z to the negative fifth actually means that I have 5 z's in the denominator. And down here, z to the negative 2 actually means that this belongs in the numerator, right? So here, where are there more z's? Okay, this is z squared divided by z to the fifth. Well, if I cancel 1z with 1z, 1 here with 1 here, are there any left in the numerator? No, they're all left in the denominator. Does that clarify your question? Really?
Yeah, a little.
Okay. So we identified that x belongs in the numerator. We see that all we have is a bunch of y's in the numerator. So let's put them together. I've got 3 plus 1 more is 4. And then like I just said, you have more z's in the denominator. So when you cancel or subtract those exponents, you have z cubed left in the denominator. And that's it.
Do another one like that.
We'll see if I have another example of that.
Why were there coefficients in it before?
Why were what? Oh, because last class I pointed out that if you have coefficients, you just divide them like you normally would. Okay? So let's do another example, and let's include coefficients. Say we have 4x to the negative 2 z to the fifth divided by 6x z to the negative 2. And you're asked to simplify this expression. Okay?
You have to move the 4.
No.
Yeah, do you move?
No. The 4 is just 4.
If it's negative.
Then it's a negative 4 like we've been using. Okay? The only time we flip is when the number has a negative exponent. If the 4 was also being to the raised to the negative 2, this is what